All right, welcome to our second class. In our first class, we learned about the coastal environment. We defined what a coast is, what environment is, and very many other parts of it. We say there are 4 different types of coastal environments. Can you name them, please? What are they? The rocky coastal environment, muddy coastal environment, sandy coastal environment. So those are the coastal environments. Now, we learned about a few things, what causes them, and here we are to continue with the same currents. We defined what currents are, and we said these are, or it refers to the large scale continuous movement of water in the sea and oceans. So we shall move straight to our next part, and that is geology. Geology refers to the arrangement and composition, how rocks are arranged and how are they composed. Okay, so geology refers to the arrangement and composition of rocks in or found in an area. Coastal environments are affected by their own geology. How the rocks are arranged and composed in an area affects its coastal environment. This means that the arrangement and composition of rocks at the coast cause it to change due to the daily interaction of water and land. This shows us that weak or non-resistant rocks like limestone are eroded or break down so quickly than the strong or resistant rocks. Okay? Yeah. So please take note of that. I'll ask you, what is geology? Explain the following terms. 1, current. 2, tides. 3, geology. Next, types of ecosystem. Ecosystem refers to how communities of plants and animals interact with each other, as well as the environment. In other words, how do plants benefit from animals, and how do animals benefit from plants within the environment, within their surrounding, is what we are referring to as ecosystem. Examples include the mangrove and the cliffs or the coral reefs. They are affected by the rates. They affect the rate of change of coastal environments by reducing the strength of waves on the coast. So the examples above that we have seen, the coral reefs, how are they important? They are important in that they reduce the strength of waves. The waves will come so heavy with, remember I told you waves is the up and downward, okay? So it will come when it's very heavy, but before it reaches the coast, it reduces. So that is because of the mangrove. Human activities. Human activities such as coastal rather human activities change coastal environments by fishing, trading, living, and also engaging in recreational activities in these environments. So the activities that me and you do make a change within the coastal environments. You may be doing activities, like which activities do you do? Tell me. Huh? Bush burning, deforestation, dumping waste, all these, building houses, building ports and beaches, marines, all these make changes on the coastal environment. Let's continue. This means that when humans carry out their daily activities near the coastal environments, they affect them or cause change on them. Such activities include building marines, ports, beaches, and also dumping waste that cause pollution. Okay? You go and dump the garbage somewhere, they're going to cause pollution. And at the end of it, it is also changing the coastal environment. Okay? So please don't forget waves. How are waves formed? Okay? How are waves formed? Waves are formed or developed when energy from wind blowing across the seas or oceans is transferred to the water surface. Explain briefly how waves are formed. Okay, I've told you waves are formed when energy from wind blowing across the seas and oceans is transferred to the water surface. The movement of waves is affected by the direction of wind. Okay? The movement of waves. If let's say the wave is going north, but wind is blowing in the west, then the wave is definitely forced to change the direction and it will follow the direction of the wind. On shores, winds push waves towards the coast. When winds break, water rushes to the beach or the shores, and this is called swash. When swash comes to the beach or shores of the sea, it carries sediments and deposits them on the beaches or shores. And when swash weakens due to gravity, okay, it returns back to take the U-turn. It turns back into the sea or oceans. And this is called backwash. Please take note between these two. What do you understand by the following terms? 1, swash. 2, backwash. All right. When does backwash happen? It happens when sediments are carried back from the beach or showers into the sea or oceans. What is swash? This is when waves break and water rushes back. Water rushes to, what is swash? This is when waves break and water rushes to the beach or showers. It rushes the wave breaks off, but what will the water do? It will have to continue, and it goes at a very high speed to the beach. Okay, what is backwash? Backwash, this is when swash weakens due to gravity and it turns back into the oceans or sea. So we talked about waves. We are talking about waves, waves, waves. What are waves? Let's see what waves are. What are waves and how is a wave formed? What makes up a wave? We shall see all that. Types of waves. There are two types of waves. One, the constructive waves, and two is the destructive waves. Constructive waves. These are also known as swells and spilling breakers. They have low energy. They have very low energy and they break before reaching the coast. If a wave is moving, but before it reaches the coast, it breaks off. Then you should know that is a constructive. They usually happen in calm wave. They usually happen in calm weather on sloping coasts. It doesn't need for the weather to be so windy. It will be calm. You sometimes go to the beach and you see the water is really calm. Then this is a constructive wave. But there will be some little, not so large, very small waves. That's what we are referring to as constructive waves. They also have strong swash. Swash is movement, it goes ahead. And backwash is weakens its back. So they have strong swash and then weak backwash. Okay. Destructive is the opposite of the other. Whatever we have seen at constructive wave is exactly what we are looking at destructive, but in an opposite way. Okay? Destructive, these are also known as langing and sugaring breakers. This is because they break violently on the shores or coasts with very high energy. Very high energy. This is what exactly I told you. The other one we said with low, very low energy, and here with very high energy. They usually happen on steep slopes of the coasts, and that is why they have weak swash and strong backwash that move the rocks. Let's see their differences. Let's see their differences. We can have a table. Here is our table, and on this table, we are looking at the differences between the constructive and destructive. Okay. Constructive waves have low gradient and low energy environment. See that? But with destructive, it's the opposite of that. For them, they have high gradient and high energy environment too. About the constructive, they are small and they have low waves. Remember we said they happen in calm weather. So if the weather is calm, so you don't expect the wave to be very large and strong, definitely. So they have small and low waves. The destructive have high wave height. Sorry. Destructive have large high waves. Constructive have small low waves. The destructive have large high waves. 3. Constructive waves have long wavelength. The other one have high wavelength. Constructive waves have low wave height. The wave frequency is 6 to 8 per minute. They have more swash, which is more powerful, and they occur on gentle slopes and scattered coasts. That's what we can say about the constructive. On the other side, for the destructive one, we say they have high gradient, high energy environment, large, high waves, high wave height, short wavelength. Wave frequency is about 10 to 14 per minute. Remember the other one has what? 6 to 8 per minute. And this one is 10 to 14. So you can see that. The lesion process is more prominent at the destructive wave. And on the other side, deposition process is more prominent. So that's